Hi everyone, and welcome to our first physics video lesson. This one's going to be on unit conversions, just kind of going over some basic things that you've already done in other science classes. We're going to go over the metric system, the basics of it, and some of our units that we'll be seeing in physics. Some basic conversions, some speed conversions because we do a lot of those in physics, and also some rotational motion conversions. We'll see those a little bit later. So let's get started. The metric system is the system that we use primarily in physics. It's very easy to use because it's all based upon multiples of 10, as you've already heard. The three units that we use the most are length, and we use meters for that. We will use a mass unit of grams, and we will use a time unit of seconds. And the beauty of the metric system, as you know, is if we had 1,000 grams, that would equal 1 kilogram. So we're really just trying to find the conversion factor that works best for us. And what I'd like to do now is just kind of show you some examples and go through some basic examples and then some more complicated ones, just as practice for using the metric system and converting units. So as you can see here in our first example, we're going to try to convert 52 grams into kilograms. And so the first thing I'm going to do is write what I am starting with, which is 52 grams. And then I want to write my conversion factor, what I'm going to be multiplying that by. And the general idea is that if I want to eliminate grams and go 2 kilograms, I want to have what I'm trying to get rid of in the denominator of the fraction and what I'm trying to go to in the numerator. So I want to have grams in the denominator and kilograms in the numerator. And for this, there are 1,000 grams in 1 kilogram. And when I multiply, grams cancels, and we're left with kilograms. So we end up getting an answer of 0.052 kilograms. And I like to box my answers so that they kind of stand out a little bit. If we are dealing with a unit conversion that's a little bit more complicated, such as 52 kilometers into millimeters, we would have to do 2 conversion factors. So I'll try to do this one out. 52 kilometers, and in 1 kilometer there are 1,000 meters. And so I want to work back to my base unit first. And my second conversion factor, because I'm eliminating kilometers, I want to now eliminate meters. In 1 meter, there are 1,000 millimeters. And when I do all the multiplication, I end up getting 52 million millimeters. And what I think you should try right now is hit the pause button and try to do the second example on your own, and then when you're done, hit play again, and I will do the answer out, and you can check your work and see if you're right. So hit pause right now and try the second example on your own. Okay, so you've done the second example, and now I'll do it out. It's going to be 100,000 centimeters. And first I want to get to just plain meters, the base unit. So there are 100 centimeters in 1 meter. And if you didn't know what the H was, the H is hectometer. So there are 100 meters in 1 hectometer. So I'm dividing 100,000 by 100 and then 100 again, and we end up getting an answer of 10 hectometers. And those are what I would call two-step conversions, a little bit more complicated. You might see a couple of those in physics. The next example is actually far more common for us to see, and these are speed conversions. Speed conversion is something that we do a lot because we do a lot with motion. And in this case, really what it is, it's kind of like a two-step conversion. We want to convert 40 kilometers per hour into meters per second. So you have to pick. You have to first convert distance units and then time units, or you can do it backwards and convert the time units and then the distance units. I tend to do the distance units first, so I'm going to convert just like we did in 1 kilometer. Sorry about my handwriting, just getting used to the new software. There are 1,000 meters, so the kilometers cancels. And then I have to do the time conversion. In 1 hour, there are 3,600 seconds. And when I do the calculation out, I end up getting an answer of 11.11 meters per second. Meters per second is probably our most popular speed unit. Sometimes, however, we want to take a meters per second value and convert it into something like kilometers per hour, which is what you might see on a car. So for this example, what you should try to do is hit the pause button, do it out on your own, and then hit play and see how you did. So you can hit the pause right now and do your example on your own. So hopefully you did the example on your own, and I'm going to do it out right now, 24 meters per second. And I'm going to convert distance units first. You don't have to, but that tends to be what I like to do. There are 1,000 meters in 1 kilometer. So meters cancels, and I'm left with kilometers for my distance. And then for time, there are 3,600 seconds in 1 hour, so seconds cancels. And doing this math out, you end up getting an answer of 86.4 kilometers per hour. I'll box that answer. So those are some more complicated speed conversions, and we'll do a lot more of those. We'll do some practice as we go. The final conversion that you might see in physics is a rotational unit. Rotation talks about some type of circular motion. There's 3 units that you could possibly see with rotation. The first one is degrees, so there are 360 degrees in 1 full rotation. That's also known as 1 revolution. And if you were to do it in radians, that would be 2 pi radians. These are useful because they are equivalent to one another. Just like 1,000 grams equals 1 kilogram, 360 degrees equals 1 revolution, which equals 2 pi radians. So, if I'm going to try to convert 4.27 revolutions to degrees, I would multiply by a conversion factor of 1 revolution is 360 degrees. So 360 degrees over 1 revolution is equivalent to 1. And when I multiply out, I end up getting a value of 1,537.2 degrees. As you can see, the units of revolutions cancels. And I'll box my answer as best I can to make sure that my answer stands out a little bit. Hit the pause button and see if you can do example 5 on your own as a little bit of practice. So hopefully you had some good success with number 5, and I'm going to do it out right now. 562 degrees to radians, conversion factor, there are 360 degrees for every 2 pi radians, and that's equivalent to 9.8 radians. I ended up just using a value of 3.14 for pi. So these are some sample unit conversions that we have, some basic unit conversions, and I hope that it went well, and if you have any questions, we can go over them in class the next day. Thanks.